At this stage, we've created the entire script. It's now in 3D, and we know that it all works because when we change some of these sliders, we know that it will update, and we've made sure of this throughout the entire process. So now what we're going to do is take this script and we're going to develop it further. We're going to take some of these outputs and create an array. So this has been the process the entire time, starting from the beginning from scratch, and now getting into the parametric 3D portion of it. There have been many steps in between, so if you want to check out the videos and download the script to see where we're at, check out my website, CompetiDavid.com. You can find it there. So now let's jump into the next steps to see what we can do with the module like this. At this stage, what we need to do is to create an array going in the X direction. So the first thing we need to do is create a move component, and that will let us move this in the X direction. So let's start here, and we'll go to the walls output, and we'll be using that. So I'll go here to a move component and use the wall as the geometry input. And the motion is going to be in the X direction. And that's the reason why we want to array it in the X direction, is because the walls here and here are blank, which means that we can use it to array in one linear direction and then have egress and the doors not have any issues. Now we'll go here to motion, go to unit X, and now we need to figure out what's the size of this module, which we have in terms of a polyline. So if you look here at this bedroom layout cluster, we have the output of the area. This area here, or the perimeter, is composed of a polyline. So now what we'll do is take this polyline and we will explode it. So we'll go here to explode. Now we can take one of the segments. So we'll go to item or list item. So we can pick a specific direction. Notice that the index of 0 is giving us as the item the curve that we want. Now we don't know if it's how it's arranged, if it's going this way or this way, but what we'll do is we'll take this and we will actually use the length of it. So now with using that length, we'll plug that in to the X factor, and notice that it copies it over exactly to the other side. Now sometimes you want this to overlap, so that's where we can actually subtract. So we'll do minus or subtraction, and we'll subtract the thickness of the wall, just one of them. That's going to be here, wall size 3.5, and we can use a number component that is empty, and we'll place that wall size in here. The reason why is because we want to right click here on the input, go to wire display and go to hidden. And so now it's not in the way and kind of confusing anyone. This will then be used as the subtraction value, and therefore giving us an overlap, because at the end when you have 2, then you can use the Boolean union component to bring it all together. So let's do that. Let's take a look at this and go to union or solid union, and this will let us plug in both of these. Holding down shift, we can add another one, and if you take a look at the output, it says 2 values, and if we flatten it so it comes in as 1, then we get the closed brep. Now we can hide the previous steps, and you'll see that it actually creates a set of 2 bedrooms that are exactly the same. And as long as we have the size of the room, we can increase these and they will happen at the same time. So this would technically be one module, but what happens is if you want to create an array, we wouldn't want just one input for the move. We would actually want a series. So that's where I bring in a series component. Then I'll use the output for the amount that we're using to array, and we'll use that as the step. The count or the start, we'll leave it at 0, and the count will actually change. So we'll go to, 6, count of 6, and this will give us a set of numbers that are stepped by 234.02, and it starts at 0, and it gives us 6 of them. So those are the numbers that we'll be plugging in: 234, 468, 702. Those get plugged into the factor, and as long as we use a graph for the array, let's see here, and a graph for this array, what happened there is that we don't need this wall input for the union because that would be overlapping with some of ours. And so this is how you do it. You create the array, then you put it together like this, and now we have the ability to array them in a specific direction, create as many as we want, and then still be able to change the size. So let's say I want the bedroom to be 12 feet by 12 feet, and I want the walls to be 5.5, and the window size to be 8 feet, and the window location to be 2.2 frame offset. That's for the 2-dimensional portion of it. And we can change all of these: the door depth, the closet size, if you wanted it to be more like maybe a walk-in. So these are the cool things that we can do with parametric design. Now, we only took one direction of this tutorial, which was to array it in one direction, but now I want to show you a different iteration to this, so you can see that there's many different ways that we can figure out an array depending on what you're trying to do. So I'll be going over one more exercise that can show the power of parametric design. Okay, so now with this output, so this is what we've created today. And so far, it's only one slider for the X array. And I like to keep this clean. I've been noticing that I tend to pan a lot, so I'll be more subtle about scrolling in and out and showing you what I do here. I don't want to lose you guys in the middle of the tutorial. So, okay, now that we've done all of these steps to create this array, we're going to just select this, middle click, and disable preview, and bring back the original wall. So we're going to be another array, but this array will be a little bit different in the sense that we'll be taking this and mirroring it to the other side. So we'll take this, create a mirror component. We'll use the walls as the input for the geometry, and now we need a plane. The thing is, the plane has to be on this side. So what we'll do is we'll do the same thing that we did before. We can use the exploded line segments and use a list item to extract this line segment. So we'll go here to item or list item, and we'll be picking one of these segments, which we have 4. So we know that index of 0, like up here, is this one. So if we go to 1, or let's just bring in a slider of 2 so we can have a range of numbers. If we go to 1, we'll see that this is the line segment. Now I can use that line segment to extrude. And all we need is a plane as an input. So if I take this item and I plug it into the base input to extrude, and I go extrude in the Z direction, I can even come in here and set a specific vector, but I'll go to unit Z and show you here. We've created this tiny extrusion, and that's actually what we'll use for the mirror. So let's disorganize, bring in the mirror plane. Okay, here's another thing that I noticed is we can probably use the inside line segment, but regardless, let's say we have now 2 of these. We can also move this in the negative X direction by the amount of the wall thickness. So we'll do that again here. We'll go to move, the mirror geometry, and the negative X. And we'll be using the X factor. Gotta use 3.5. That's what we'll use, this number. Plug it in here. So it moves it back by 3.5. Now we'll hide this part. We have these two as our module now. So now what we'll do is we'll take those two, and the reason why this would be different is because you have the door here, and that allows you to design other things around here. When you have one door on one side and one door on the other side, you don't have the ability to group the circulation. This is a little bit more efficient in terms of grouping the circulation, but obviously it's up to whoever designs the floor plan to make those decisions. So with that being said, we'll take this and we'll create a union, solid union between the mirrored and moved module and the original. And when you flatten the input, we'll have one closed brep. And now we can disable this wall. And you can see that we still have all of the capabilities that we had before. But now when you mirror it, it just, like I said, it makes it more efficient in terms of the circulation there. But we also have 2 options. So you're not just stuck with this. You can also do an array of 2. Right? So we have both options within the script, and that's pretty useful in terms of not just this, but in other designs where you can have multiple designs within one script. I'll hide this, bring this back, and now let's create an array of this module. Okay, so I'm going to show you another technique of a different way that we can figure out the overall length of this, especially when you have one closed brep. What I like to sometimes do is create a bounding box, and there are different ways to do this. Either bring in a box component or there is a bounding box component, and this one allows you to pick a specific plane to align with. For this one, we won't need that, so we'll use the box input. This creates a box around whatever geometry you have. So it's kind of like the bounding box command inside of Rhino. With this box, now we need to go to deconstruct brep. What deconstruct does is explode the entire brep in the same way that we explode a curve, but this is going to be exploding a 3D object. So we'll be exploding that box. So let's disable preview here. And now we're going to pick one of the edges of that box, in particular this edge. So we'll go here to item and pick one of the items. So we'll go to edges, plug that into the list. And notice that by chance, it happened to be that this, or just by the way that this was organized in the X, Y, Z, this curve is index of 0. So we don't have to use a slider, but if we did, it would pick a different curve. So notice that I have this highlighted, and when I move through the different numbers, it picks a different curve. We want to pick 0, which will let us pick this line segment. And now we can disable the preview all of this, because with this line segment, we actually just need the length of it and subtract the length from the thickness of a wall, so it doesn't overlap here. So we subtract it from this number. And if it tends to go very far and overlap with things and confuse, I like to just wire display hidden. Right click, wire display hidden. And now we can create the array, so a move component using this module. So this join together union module, and the motion is going to be in the X direction. So what did we do? We created a box. To get the length to array, we created a box around it, extracted this line segment, which is the length, and we subtracted the wall thickness, so we can use this X vector to move another copy here. Now, in the same way that last time we created a series of them, we'll do that here. We'll go to series. We'll use this as the input. The count, we'll just say 3. So we'll be creating an array of 3 that steps by 299, and it creates 3 different values starting at 0, 299, and 598. We'll use that as the factor input. And now we can create an array of the module where you have the circulation. And now here we can use this space outside to create, let's say, another bedroom or something like that, or to do whatever you want. So just, you have to keep in mind that this number of bedrooms has to be multiplied times 2. So if you have 2 here, you're going to have 4 bedrooms. And I'll disable the preview here. So at the end, we have the ability to create 2 different outputs for this. I'll be using an array in the X direction, 4. I'll just leave that as a default. And you'll be able to download this to see how I came up with this, how I put this all together after we created the cluster. So this has been more of an incremental tutorial. At this point, we're going to take this, create another one here, and disable the preview of every step before, so we don't necessarily have to see it. And if we want to bring in another output, we can also do that. We don't need to change this number. This is the only other parameter that can be used as an input for this. So notice that we didn't do much else than pick the number of bedrooms, pick the array, and that's it. Everything else had already been taken care of, and we just tied it all together. So now here at the end, we can disable the preview on this, and you can see this array, disable the preview, and you can see then this array. So let me know if you have any questions. I actually noticed one last thing is this needs 2 things. It needs a merge all, so it brings it all together nice and clean and gets rid of all the creases. We'll be using merge all coplanar faces, which we need to use down here as well. And this one needs a union, solid union between all of the arrays using a flatten input. So we have one closed BREP as an output. We'll copy this down here because we want to get rid of the creases. And now this kind of like a final step to clean up your geometry when you're going to bake it as an output. Okay. Notice that that's a clean array there. All right, great. I'll clean this up, show you what I did to clean it up and turn it into a cluster. And if you have any questions, make sure to let me know. Go to the website, download it, and check it out. Thank you very much for being here, and I hope to see you on the next one.